Okay, 3.2 notes, implicit differentiation, taking the derivative of an implicit equation. Okay, so it says recall, an explicit equation is an equation like y is equal to the square root of 1 minus x squared. Okay, we have an equation y all in terms of x. Okay, versus an implicit equation, x squared plus y squared equals 1. Notice both variables are on the same side, so when taking the derivative, it's going to be hard unless we give a certain rule of saying we're taking the derivative in terms of x or y. Notice another thing, that this equation is the equation of a circle, which means this is not necessarily a function. So let's look at taking the derivative in terms of x. So remember, d of dx is another way of saying taking the derivative. So the derivative of x is 1 dx dx. Okay, so instead of just writing the derivative, we're going to write dx dx. Okay, the next one would be derivative of x squared, which is 2x dx dx. And then the next one would be 5e to the 5x dx dx. Then taking the derivative in terms of y, we have 1 dy dx. Notice how that changed. 2y dy dx. And 5e to the 5y dy dx. So whenever we take the derivative of a function in terms of x or in terms of y, we want to write dx dx, which we know simplifies to 1, or dy dx. Okay, so here it's going to give us the steps in order to solve for dy dx. So given this equation here, y squared minus 5x cubed equals 3y, it wants us to take the derivative in terms of y. And every time we do that, we are going to write dy dx. So we have 2y dy dx minus 15x squared. Notice we don't write anything there because it doesn't have a y, is equal to 3 dy dx. Okay, then we need to make sure that all the dy dx's are on the same side. So I have 2y dy dx. I'm going to subtract this one over, so minus 3 dy dx. And then I'm going to add this one over, equals 15x squared. Then I'm going to factor out a dy dx. So dy dx of 2y minus 3 is equal to 15x squared. And then solve for dy dx. So I get dy dx is equal to 15x squared divided by 2y minus 3. Okay, this would be the derivative in respect to y of the following equation. Okay, now let's look at some examples. So we have 3y squared dy dx minus 2 is equal to 4x cubed plus 2 dy dx. Well, I want all my dy dx's on the same side. So I have 3y squared dy dx minus 2 dy dx is equal to 4x cubed plus 2. Then I get dy dx by itself by factoring it out. So I have 3y squared minus 2 is equal to 4x cubed plus 2. So I get dy dx is equal to 4x cubed plus 2 divided by 3y squared minus 2. Okay, now I'm going to do the derivative of this one. But notice right here, I have x times y. This is the product rule. Remember, the product rule is f prime g plus fg prime. So when I am taking the derivative in respect to y, I have to remember to do the product rule for the x times y after I do the chain rule for sine of xy. So the derivative of sine is cosine, so this is cosine xy, okay? And then I would have to take the derivative of the inside, which is x times y. So this would be 1y plus x dy dx is equal to 10. Okay, I can divide both sides by cosine xy. So I have y plus x dy dx is equal to 10 divided by cosine xy. I can subtract y and divide by x, so I get dy dx is equal to 10 over cosine xy minus y divided by x. Okay, that would be my derivative.